the Noyo Center for Marine Science does these Science Talk series, bringing you people from all over the world. And last time that Bill came, he drove up and gave a presentation in the town hall in Fort Bragg. It was one of our first science talks, and talking about the animals that we have in common, the bottlenose dolphins and the harbor porpoises. And it was mind-boggling then, and now we're almost 10 years later that we're all here listening to Bill again tonight. So with that, I am going to hand it over to our dear guest, Bill Keener. Welcome, and thank you so much for being with us.
Thank you, Sarah. I really, it's great to be here because not only, I mean, talking about going back many years when I first presented coming up to Fort Bragg, but Noyo Marine Center is really a partner with the Marine Mammal Center. And so I really am happy to do it, and I'm glad you guys are with us out there fighting the good fight for ocean conservation and are rescuing animals on the North Coast. So that's great. I'm going to share my screen so I can get this talk started. So let me do that and make sure everybody can see everything. And so now, so it should be kind of full screen there. Is that working for everybody? Okay, great, fantastic, thanks. Okay, so a little bit more about myself. I've been involved in the marine mammals world for a long time, since the 70s, starting with the Marine Mammal Center. And I was the director of a very small and nascent Marine Mammal Center back in the early 1980s. It started in 1975. And then I was on the board, but always interested in cetaceans. I started getting going, being a whale watch naturalist, and really got interested in what was going on with our local cetaceans. And then here it is decades later, and I've returned as a senior scientist to the Marine Mammal Center, where my team, there's a few of us, work on the other part of what the Marine Mammal Center does, which is there's pinnipeds, and now we have cetaceans. And let's see here. I'm going to just make sure I can click here. Yeah. And so the Marine Mammal Center is the largest teaching marine mammal hospital in the world. And we have lots of patients all the time. We still have about 40 pinnipeds right now. And this is the slow season. We had well over 100 earlier in the year, with many different issues, from disease and entanglements, separations from mothers, like this little harbor seal. And then we've got actually, I want to just show this map for a second here too. This is how far the Marine Mammal Center stretches their range from Mendocino all the way down to San Luis Obispo. So we're very appreciative of the Noyo Marine Center's help in the northern range operations up there. So I want to really talk and focus on the cetaceans, and how the studies that I'm involved in really are more focused on San Francisco Bay, but really these cetacean species are connecting us from the coast into the bay. So I'll talk a little bit about harbor porpoises, bottlenose dolphin, gray whale in particular, because that's one I know you guys see a lot along the coast every year, and we do too. And then humpback whales. So I'll cover all four of these species, and we're engaged on studies on all four of these in some details. So this is my office, which is really nice. I get to spend a lot of time outdoors, either sometimes on a boat and a lot of times from shore watching. This is the 1 mile wide strait here under the Golden Gate Bridge, and there's a lot of cetacean activity there. All four species that I talked about can be seen there. And I spent a lot of time on the Golden Gate Bridge, and which has turned out to be an amazing wildlife observatory. I mean, you can see all these species there, and you're only 220 feet up, so you can actually get pretty good pictures of what's going on. And I'm taking some photos of a pair of harbor porpoises underneath the Golden Gate Bridge. So let's first start talking about harbor porpoises. And the real story with them is their return to San Francisco Bay. And first, just so I know people can see both of these species, bottlenose dolphins and porpoises, from shore. So I just want to show you the difference between the two, so you know which ones I'm talking about. So this is the little harbor porpoise up on top here, and the much longer curved back dorsal fin of the bottlenose dolphin is below, so you can see them. And the dolphins are bigger than the porpoises. So the porpoises are the little small guys with a little triangular dorsal fins that you don't see much at the surface. They just 1 second roll at the surface, and that's all you're really going to get most of the time. So the story is that they were not in the bay for many decades. In fact, there were no cetaceans in San Francisco Bay for many decades. And I remember I was born in San Francisco, going across the Bay Bridge when I was very small, back in the 1950s, and the bay would stink like a cesspool. I mean, there was all kinds of sewage and industrial pollution running into the bay. And that was the way it was then. There was no Clean Water Act to protect the environment. And there was just not a good place for fish in the bay at the time. But there was something else that was going on too, which was that World War II had happened. And what was going on was that there was torpedo nets and submarine nets stretched all across the bay from Sausalito to San Francisco. And that absolutely had an effect on keeping big animals from moving around the bay. So these are some photos from the 1940s here, where there was floats keeping this gigantic steel net afloat all the way across the bay. And they had a tiny little opening between these two boats that the Navy controlled every single boat coming in or out of the bay for 4 years. So we think that had a lot to do with knocking the numbers down, as well as the pollution in the bay at the time. But they certainly have come back, and the bay's a lot cleaner than it used to be. So this is really a good news environmental story in many ways. And of course, a lot of people get out on the bay. There are porpoises around now 365 days a year, but they often don't notice them. And just like this crew on this sailboat, they're just oblivious because these guys are just up for a second or two, and they're not coming up and riding on your bow like a bottlenose dolphin might. They're a little quieter and keep to themselves. But you can see them if you go out on the Golden Gate Bridge. Every single day at high tide is the best time, and you can see them moving under the bridge or coming out, or sometimes feeding on fish, which I'll show you. Sometimes we're starting to see mothers and calves, including some really, really young calves that are obviously born right in the area, right in the bay, undoubtedly. And here's another one with a mother and her young. And we see all kinds of interesting behaviors. As the ships go under the Golden Gate Bridge, they create a tremendous wake. And sometimes here's a mother and a calf porpoise that will just hitch a surfing ride in the wave of a passing ship. And it'll be behind it, not in front of it. So it's a wake behind the ship, not the bow. And we see some interesting feeding behavior. So here's a pelican and a porpoise going after this same fish, and half the time the pelican or seabirds will beat the porpoise to the punch and be able to try to get the fish out of the water. So this is what it looks like, where you've got these porpoises are much more agile than I would have guessed after, and I've been looking at them for years now, but they're doing all kinds of little acrobatic spins and stuff. So it's kind of fun to really get into, you can see right into their lives, and you're not disturbing them, of course, when you're looking straight down on the Golden Gate Bridge. It's like an aerial drone view. And then one of the more interesting things that's led us into a whole study is their social life, in particular their sex life. So I took this picture a long time ago, 2010, from the Golden Gate Bridge, and I thought, oh, finally, I got a porpoise that's leaping in the air. That's great. And then I blew it up on my computer, and I thought, wait a second, what is that? And that is a penis. and a very large penis, because this animal is probably 4.5 feet long, and this is probably 1/3 of its length. And so that's quite astonishing for such a small little animal. And so we began a detailed study of their sex life by just simply going out year after year and taking photos of what they're doing. And they have a very sort of set behavior where the male always approaches the female from her left side and more or less bangs into her, smacks her hard. And so the sex act itself is within less than a second long. And it's hard to believe that, you know, here's some video I've taken of it, and you can just watch this. That's the whole thing. Now, I'm going to slow it down. So this is 1/3 speed. And that's it. I'm going to actually, you know what? It might be worth playing that one again, just so you guys can see it, because it goes by very fast. There's regular speed and slow. And again, this male porpoise is knocking into this female from the her left side. So there's a couple things about this that is kind of astonishing, and that we're really trying to sort of figure out. So what is going on here? I mean, how could this have evolved like this? There's no other mammal that really is really like this. So it turns out there's a couple things going on. One is that we believe that 99% of the time, including the time I showed you, that is not a successful copulation. That is, that the female actually has a lot of control over what's going on, and she can move in many different ways to prevent the male from actually having penetration. And so, but the male's trying very hard, but he's always coming on her left side. So what is that about, the left-sidedness? This is something we spent a lot of time looking into different parts of the anatomy to see how they match up. And it turns out that the inside the female, in her vagina, it's twisted and turned. And so if the male doesn't approach from the left side, he's not going to have a successful insemination. So this is something we've just all kind of astonished to have learned over these last few years. And we've written a number of papers about it because it's such an unusual social behavior for any mammal. But that's our little harbor porpoises. And if you see them offshore up in Mendocino, and you see them leaping, almost certainly, basically 100% of the time we see them leaping, it's because they're having a mating event. And so that's pretty unusual. So that's worth looking at. Now, let's think about this for a second. So the porpoises, the harbor porpoises, were not in the bay for many decades. And where we see all the activity, all the mating, is immediately under the Golden Gate Bridge. We've been out on boats, we've looked for it elsewhere. It doesn't happen. It's always happening here. And we think it's just simply an effect of the social density of the animals reaches a certain level under the Golden Gate Bridge. It's because they're spread out in the ocean. When they come into the bay, they're concentrated right at the Narrows. And when they're in the bay, they spread out. When they come back, they're concentrated right at the Golden Gate Bridge. And we've seen males waiting there and will try to successive females try to mate with them as they go by. So it's really like being spread out sort of socially when you're in a rural area and you all come together for the barn dance on Saturday night. Well, the barn dance is the Golden Gate for harbor porpoises. So that's their social dating scene is happening right there. And you can also imagine that if they're for decades not able to use this area because they've been abandoned it because of pollution or heavy ship traffic and like this big submarine net that was right there, that they actually lost something for their population, that this is actually a benefit for them. This geographic area, this submarine little canyon, is actually of great benefit to their the local population. So it's kind of an interesting story. Bottlenose dolphins. Now, this is an animal that is really new to us. We've only started seeing bottlenose dolphins at all about 10, 12 years ago. So harbor porpoises were always historically in the bay, and then they left the bay and are back. Bottlenose dolphins appear to be new to our area. So here's San Francisco with the kinds of scenes we're seeing. Now here's a couple of adults with a very young animal, a calf, between them. This is at Ocean Beach. And here's a picture I took inside the bay. This is the Richmond Santa Fe Bridge in the background there. And this is that red rock island that you see when you cross that bridge. And so their story is that until 1983, all the coastal bottlenose dolphins, the ones that stick really close to the coast, were only in Southern California, south of Point Conception, where the water's warmer. But there was a big El Nino in 1983. I actually remember this. And the bottlenose dolphins used that opportunity of warm water to come up to Monterey Bay. When the water cooled afterwards, when the El Nino was over, the bottlenose dolphins stayed. They learned how to navigate, how to find food, and they didn't leave. And over the years, they've been creeping further north towards San Francisco. And now they've been getting to Sea Ranch many, many times. And some of the folks have helped us out there, Craig Tooley and Karen Wilkinson and others who've been taking photos and have been very helpful in our research there. So our latest paper is sort of redrawing the map and saying, okay, now Sea Ranch really is kind of the northern range, but they're going further north, I'm convinced, and you'll be seeing more of them in Monterey Bay. And we'll talk a little bit, in Mendocino area. So we'll talk about that. So we're seeing them now, not every day like the harbor porpoises, but they cruise up and down the coast. So they're much more hit and miss trying to find bottlenose dolphins in the bay or along the immediate coast. Here's a photo I took straight down from the Golden Gate Bridge on a pair. So you can see the kind of view you can get straight down. And so one of the nice things about bottlenose dolphins is that they're very long-lived, almost as long as human beings, 50, 60 years. And they have unique silhouettes on their dorsal fins. So you can take a photo and be able to match these individuals over decades. So here's Bliss, who was first seen in San Diego in 1982, is one of our 120 different animals in our photo identification catalog. And photo identification is absolutely critical to following many species, the humpback whales, gray whales. People are working on orcas and all kinds of other species on our coast, and using photo ID is a necessary tool. So the coastal bottlenose dolphins are definitely moving north, and that's what I want to show you a little bit. Here's a fantastic photo by Stan Angel, who was taking this at Salmon Creek in Sonoma. So here's a view that, surfers up in our area don't get to see a lot. In Southern California, it's common, but it's great to see it here. I don't know if you remember this, but the big Tongan volcanic explosion that created a tsunami last year, well, the dolphins were using that. They were actually surfing these huge waves off Sonoma County. And here's a great picture by Craig Tooley up in Sea Ranch of a mother and a calf in a wave. That's kind of a cool photo. I really like that. So we can look at some individual dolphin movements that we've put together. And so here's Bliss that I mentioned before. So here she is. She starts in the 80s in San Diego. She moves up in 99 to Los Angeles. Then in 2006 to 11, so she spends 5 years in Monterey Bay. Then she ends up in San Francisco. And then at one point, when there was warm water, she went all the way up to Humboldt County, but then came back and didn't stay further north. So sometimes they'll make these little exploratory movements up further north, but might come back. And partly we think it depends on the water temperature, but partly it depends on if they've got others of their kind up there, if they're sort of making colonial, little band of brothers and sisters that can move north together or not. So here's a different. This is Erestina. Now Erestina has been one of the sort of less exploratory dolphins in a way. She started her life in Monterey Bay and has only moved really to the San Francisco Bay, although she spent a little time at the Russian River mouth. She's been seen. Then all of a sudden, and I want to point out this picture on the lower left. This is last November. So this is the 10th of November in 2022. And this little arrow points to a little nick, a very tiny nick in her dorsal fin that didn't appear in all the catalog photos. So one of the things you do when you have a photo ID catalog is you've got to pay attention to what's called mark evolution, meaning the marks on them can change over time, and you've got to be aware of that and stay alert for it. So then what happened is that Shari Goforth took these photos in 19 days later. So from San Mateo County all the way up to Anchor Bay in 19 days. So totally unexpected for this particular animal, but there she is with that new little nick that's right there. So this is the kind of really great stuff that we can get with citizen scientists helping us in our research. One of the other things that happened, this is new, is that we just published a little note on this, is that the coastal bottlenose dolphins really stick close to the coast. They're usually no more than a mile, couple of kilometers from the coast. They like to hug the rocks, hug the beach. And here they ended up all the way out at the Farallon Islands for the first time. And that was in 2019. There was at least 3 of them because 3 of them were photographed. But this is like 30 or 40 kilometers off the coast. And that means these guys are really exploring this new area north of in Northern California. And I expect they will continue to do so. And who knows where they're going to end up next. So stay alert for that. And one of the things that happens as these bottlenose dolphins move north is they're interacting with harbor porpoises. There's thousands of harbor porpoises in our area between San Francisco and Mendocino, 10 to 20,000 between here and San Francisco and the Oregon border. And there's only a few hundred bottlenose dolphins, but they're bigger. And some of these males, young males in particular, seem to be known porpoise aggressors. They will attack porpoises once in a while. It's not really, we think, affecting their population, but it's an unusual sort of social event where they're attacking and sometimes killing these porpoises. And we end up with them at the Marine Mammal Center, a few each year, and doing necropsies. And it's very obvious that they've been killed by dolphins. So that's something we're keeping an eye on too. But again, it shows you that as climate change happens, water's warm, it gives some species a chance to move, and that brings them into contact with species they haven't had a lot of contact with, like harbor porpoises here, and things can happen that were, unanticipated. The other thing is, of course, is that in Northern California, they're able to feed on things they can't in Southern California, like king salmon here. And so we'll see where that goes. But I think that's one of the things that's really attractive to these animals, is that they've got this new different kind of food supply with these big fish that they can easily handle. And they are having babies here. So these little vertical lines that you see on these little calves, these are called fetal folds. And it's because the animal, the little baby, is folded up as a fetus inside the mother's uterus. And when it comes out, it has stretch marks for a few months. And these stretch marks will fade away, but it shows you that there's very, very young animals in our waters. This is off San Francisco and Marin. All right, let's go to the big guys, the whales. So gray whales are pretty interesting, what's been happening recently with them, because we've started to see them a lot in San Francisco Bay when we didn't before. I've been out there for many years looking from the bridge and stuff, and maybe we'd see 1 or 2 gray whales a year pause on their migration, come into the bay, stay a few hours, and leave. And that's it. So you'd see that maybe 2, maybe 3 times a year. But all of a sudden, things change, and we've had what's called an unusual mortality event over the last few years, starting in 2019. And that meant many more whales are dying along our coast. And we're talking about a population that had been probably 26,000 along our coast is now down to 14,000. So they've had a 50%, almost 50% drop in their numbers, thousands dying over the last few years. And we believe it's mainly because most of them have been starving. They have not been able to find the food they normally get in their Arctic feeding grounds. They breed in Mexico in the breeding lagoons, and they move to Alaska in the summer. And so what's happening in San Francisco Bay is that we're seeing a lot more of them. This started in 2018, but really by 2019, we were saying, we saw 25 different whales in the bay that year. And so that just completely stunned us. It's like 10 times the normal amount. And several of them were dying. Some of them were dying from malnutrition. Some of them died from being hit by ships. And some of them were both, meaning they were hungry and starving and probably not very alert. They were probably weak, and they got hit by a ship in the bay. So we at the Marine Mammal Center do necropsies on each one to try to figure out the cause of death. And that was mostly, it's been ship strike or malnutrition. And so this year we've had the longest residency times of these gray whales in the bay. So one was in the bay for 80 days, which is a record. And that whale was hit, just grazed and just barely hit. And that's this scar here that's left on its back, was hit once by some passing boat. I'm not sure what, could have been a ferry boat or a big ship. But then that weakened the animal, and it later died. So just not even an immediately lethal blow from a ship can cause a downward spiral on these gray whales. And but staying that many days in San Francisco Bay is really part of the problem. So we think that with the end of this unusual mortality event is getting over with. That is, it's receding, and the numbers of whales that are stranded on our coast are coming back to normal, which is a low number. So we think maybe the whales might not come into the bay as much. However, what I think is going on is that they've actually learned how to navigate in San Francisco Bay, and they are finding a little bit of food there. So let's talk about their feeding. Gray whales are unusual. They're bottom feeders. They don't really they're not known for eating krill in the water column. They can eat fish, although it's very rare. And I'll talk about that more in a minute. But they are bottom feeders, and they'll roll and sort of suction up mud from the bottom and filter it out through their baleen plates and take the little invertebrates, the little worms and crustaceans they can get, and that's their protein. There's not a lot of food in San Francisco Bay for them, but I guess they can get a snack. And that's what we've been seeing going on. And so here's our drone footage from this year in San Francisco Bay. That's our little research boat in the bay. And look at this. We've got 2 gray whales are going to come up here with these mud plumes behind them. And those mud plumes are the evidence that they were feeding on the bottom. And so, and I think one of these, this one, see, I got a couple of mud plumes behind it. And here's another one. Look at this spot on this whale, this big white spot on its left side. So that's that whale. And it's in a very busy area. This was just south of the Bay Bridge in the anchorage for all the ships and some of these big, this is like an oil tanker and other kinds of ships all in this area, along with the gray whales. Now, last year we got an amazing opportunity to see fish feeding by gray whales. And we're just about to submit a little paper on this. And this is the first time I've ever showed any of this in a talk. So this is all new to take a look at this really rare fish feeding event. What happened was that somebody said, oh, they're feeding on fish in Pacifica. We ran down literally the next day. And that phenomenon lasted for 3 weeks in Pacifica last June. And so we saw was lots of these, well, several, half a dozen of these whales, and they were all on their sides moving through a very shallow water. This is like a breaking wave near shore. And they had they almost always rolled onto their right side. That's just the habit of gray whales. And they stuck their left pectoral flipper into the air. Their fluke's down here on the right, but their pectoral flipper's here. And so we would watch them do this as they're charging through schools of fish. And here's lunge feeding, which has never been photographed before, on anchovy. So here this whale is just smacked down on a whole bunch of anchovy, and they're just literally flying out of the water, including some being like tossed aside and out of the whale's expelled water as it tries to filter out the water and then swallow all the fish. So this is something that has just never been photographed before. So I wanted to share that with you because it's really cool, and it would be great to see if anybody else sees this kind of behavior. Now that one of the things we try to do is, of course, photo identify these animals. It's not as easy with gray whales as because they don't have a dorsal fin, and so they don't have what a bottlenose dolphin does. And half the time, most of the time, in fact, for us, they don't even show their flukes. So we're left with just matching spots or scars on their side. But here's one you can see over 3 years, we've been able to get this one animal. And it's got this scar here on the back and these little crisscross scars. And so this is definitely the same animal that's been seen 3 years in our area. And we've got about 90 great whales in our catalog just from 2018 on, as before we had 0 because we just weren't seeing them enough. But what's interesting is that we've been able to, because these whales rolled onto their side so much, and we're spending so much time moving through the water that way, we were able to tell them apart by their flipper pattern of their pectoral flipper. And that's never been done before, but it's quite easy to do. In fact, it's easier than actually looking at the sides of the animal, the flanks, by looking at these really very different flippers. We could tell them apart quite easily. And so that was kind of an interesting new addition to the methods we use for individually identifying these animals. Now, one of the things is that when we saw these animals feeding in June, well, by June, they really should have been in the Arctic feeding on the bottom animals, the small invertebrates that the main population does. But it turns out there's also a bunch of gray whales stop off in Oregon and Washington and Vancouver Island, and they're called the Pacific Coast Feeding Group. There's only a couple of hundred compared to 14,000 that go to the Arctic. There's a few hundred at most that do this stopping off. They don't make the migration all the way north. And maybe it's because they get outcompeted up there, or they just go, why should I migrate when I can get enough food further south? And then I've got a shorter distance to go to the breeding areas in Mexico during the next fall. So, and this is one thing that Scott and Tree Mercer and Shari have been looking at in the Point Arena area. They had a poster at the Society for Marine Mammalogy last year, which I think is really interesting because we're seeing similar kinds of summering gray whales in San Francisco Bay and the Farallon Islands. So I think if we put this story all together over the next few years, it's very possible that what we're seeing really is the Pacific Coast Feeding Group really includes our area, and it's not just from Humboldt County north. So we'll see if that comes to pass. Now, the last species I want to talk about is humpback whales. And they're really interesting animals to look at for their behaviors, because they're really active at the surface sometimes. And they're big. They're bigger than gray whales. And one of the interesting things is they can feed on krill or they can feed on fish. Some animals, some of the whales out there, like say blue whales, are really krill specialists, and they don't eat fish. So we're not going to see blue whales coming into San Francisco Bay because there's no krill in there for them. There is fish, and that's why we are seeing humpbacks. But to begin the story of humpbacks is they've been in San Francisco Bay before, but unfortunately, only after they were harpooned offshore and dragged in through the Golden Gate and out to Richmond, where the last whaling station in America was operating until 1971. And what were they doing with the humpback whales back then? Well, they were turning them into pet food. And it's amazing that lasted this long in our area, but that's what was going on. So when that whaling, the last humpbacks were killed around 66, and the whaling station, which was getting other animals like sperm whales and stuff, closed in 77, that was the end of whaling for the United States and for our coast. So the population of humpback whales has been recovering ever since. When you stop hunting them, it makes a huge difference. So when I started looking at humpback whales in the 70s, there was probably 2,000 in the whole North Pacific. And now there's 20,000, so 10 times that amount. And there's more mouths to feed. They're looking for more areas to find food. And some of the time, the krill offshore is not quite as abundant as in some other years. So they start looking around for fish. And we think that's one of the reasons there's coming inshore. And so in 2016, for the first time, we saw these humpback whales coming into the bay to feed. That was the very first year. Now, there have been a whale or two in the bay, like Humphrey the Humpback in 1985 and 90. There's been Delta and Dawn, a mother calf pair, went all the way up to Sacramento in 2007, but those whales were lost. These whales are not lost. They're not getting lost. They know what they're doing. They're coming in, they're navigating in the bay, they're finding food, and then they're leaving. So it's pretty interesting to see these. These are truly the urban whales. And you can see that the background here is they're the neighborhood whale. And that's something I never thought in my life I would see. And here it's happening. And this is the view I get from the Golden Gate Bridge, looking down on these guys. So you can actually smell them sometimes. You're so close to them. It's incredible. You get just some amazing views. So this is what it looks like. A little video I took just to show you from the Golden Gate Bridge. And so the best time to see these guys would be in the summer into the fall, into October. And then they're going to go down to Mexico or Central America, where they breed. And these whales are threatened or endangered on the U.S. species list. So it's not like there's thousands and thousands, many, many thousands of them. The Hawaiian ones that winter in Hawaii are a bigger, separate subpopulation of humpback whales that are doing pretty well, actually. But our whales migrate along the coast from Mexico, Los Angeles, and up into our area to feed. And they're just subject to a lot more human interactions, entanglements, getting hit by ships. So they're still vulnerable. And so why are they here? It's about feeding in the bay. Here's three of them feeding cooperatively and simultaneously under the bridge. And if you look carefully, there's the anchovy. So the same anchovy that the gray whales were eating in Pacifica, the humpbacks are following right into San Francisco Bay. And there's lots of anchovies in the bay at times. Sun has many, many feet. These shoals can be 20, 30, 40 feet thick of anchovies in the bay, the entrance to the bay. And that's what it looks like when a whale is coming up and the thousands of anchovy are trying to get out of the way. And so here's the baleen. The pink is the palate, the hard palate roof of the mouth of the whale with the fringy baleen on the side that filters out the water. So we photo identify them, and we use the underside of their flukes for that. And they're all different. They can be all categorized and identified. And sometimes we don't get to see the flukes every single time. So here's a case where last year we saw this animal with a calf. And notice it's got an oval scar on its side below this very interesting, kind of unusually hooked dorsal fin. Well, that's an animal that I saw in 2019. It's the same animal, but now it is a she, and she has a calf coming into our waters. And we nickname these animals. Most of the names are given by different researchers as they find these animals either in Monterey or Southern California or Mexico. But what we do is we put their photographs into an app, a little thing you can use online called Happy Whale. And Happy Whale matches automatically all these whales from the Pacific so that we can tell which one's which and where they're going and can track their movements, which has been great. Now, the other thing we've done is we really wanted to understand their behavior inside San Francisco Bay. We think they're feeding, but if you don't see them lunge feeding at the surface, how do you know whether they're feeding underwater or not? I mean, maybe they're going down and finding food, maybe they're not. So the way to get at that is to put a little temporary tag on them and find out what they're doing. So that's what we partnered with Cascadia Research Collective out of Olympia, Washington, and they came down with their crew to put a few little tags on an animal. So I'm on the Golden Gate Bridge taking this picture of this whale they just tagged a minute earlier. Now the tag is just held on by suction cups. It's not affecting the body. It's not in with any kind of barbs or hooks. So this is just going to last a couple of hours, but you get a lot of data from it. You get the time, the depth, temperature, but also more than that, what's called kinematics. That's the 3D motion of the animal can be interpreted by this sensor package. And so here is this tagging right there. Boom, right on the back. Very easily done. And these guys have been doing this for years and know what they're doing. This was in San Francisco Bay. So what do you get from that? You get a little map that's a little satellite map. Every time the whale comes up, it sends a ping to a satellite. And here's the Golden Gate Bridge is, well, here, stretched between San Francisco and Marin. So that whale was tagged right here first. It circles around, goes under the bridge. That's when I photographed it. It's in blue line. And that blue line mixes with the red line. So that's a different, separately tagged whale. So these whales were feeding together for a while. So let's take a look. And this is right in where the ships are coming in to the entrance to San Francisco Bay. So let's take a quick look at this. Here's the red and the orange whales. So the two different whales tagged, and they're synchronously going down together, surfacing together and coming down. Each one of these black little squares, lozenges, is a feeding lunge. So they are feeding at about 100 feet, 30 meters underwater. So this was the proof that we suspected that these guys aren't just surface feeding. They're going down and finding the fish wherever they need to, the anchovy, and feeding on them. Now, what's also interesting is that if we look at the depth of the keels of the ships moving through that same area at about, say, 15 meters, this is the risk zone. This is the zone these whales can get hit. They're below the ships when they get down real deep, but at the surface and for the first 15 meters, they are in danger. And that is half of their time we've calculated out. So half the time they're in that area, they're subject to ship strike. And so that's just a major conservation concern for us. And you think whales are big, they are, they're huge, but container ships are bigger, way bigger. And these guys, I've spoken to the skippers of these ships. They say they sometimes can't even see the whales. They're so sort of small for them. Now, here's another interesting thing. We've mapped where the gray whales go in the bay and where humpbacks go. And the gray whales go much farther into the bay. Here's Angel Island, Treasure Island. So they'll go in and stay in this farther area where it's shallower. And here in blue are the humpback whales, and they like to stay in the deep water, particularly right under the Golden Gate Bridge. And they feed on the anchovy here, whereas the gray whales are snacking on the bottom. So they use the bay differently. So the gray whales tend to be more in the path of passenger ferries, whereas the humpback whales are more in the path of the ships coming in and turning into the anchorage in San Francisco. So this is what it looks like. I'm standing taking this photograph on the hill above the Golden Gate Bridge, and here's this blow. I mean, it's hard to even see the whale under there. And this is an 800-foot long container cargo vessel moving through. Now, this particular vessel actually, I think, saw this whale and moved a little bit. But if it had another ship going out at the same time it was coming in, it would not have been able to move. There's very little room for maneuverability under the Golden Gate Bridge for these huge ships. Here's a picture I took last year. So I was watching this oil tanker come through leaving the bay out the gate. And then when I zoomed in, there is a humpback whale's flukes right there. So there's the shadow of the Golden Gate Bridge behind it. So this is what we're facing. One of the things we're doing about it is we're talking to the port of San Francisco about trying to slow the ships down. If we can slow them down to about 10 knots from their 15-knot speed limit in the bay, that would do a lot. It would give the captain, the skippers, and the pilots more time to see the whales, and it gives the whales more time to get out of the way of the ships as well. And when things go badly, then you get this, like last year, this famous kind of humpback whale, Fran, who'd been seen hundreds of times by all the community in Happy Whale, was found dead on the beach at Half Moon Bay, and it was a ship strike. So it's really sad. Loss of any of these animals is sad, but you lose an animal that's just so well known. You've seen her; she's had multiple calves over her lifetime. She was a good mother. It's a loss. One of the other things we're doing about it is that we've partnered with the Benioff Ocean Institute, and so they put up money to put down a buoy that can listen for whale sounds, listen for whale vocalizations. And this is out near the Farallon Islands out here. So it's about 18 miles, 20 miles outside of San Francisco. And it's basically listening for these whale sounds like blue whales or humpbacks or fin whales. And that goes up to its little buoy on top, which sends a signal to the satellite. And that can get to the Coast Guard and get out to let mariners know there are whales in this area. One of the things we found by putting this buoy down already, it's only been there a year, is that there are whales here all year long. There are no like dead seasons or seasons when there's no whales. The whales are here basically all the time, either blues or humpbacks, and they're not even really detecting grays. So the grays are on top of this. So we have a really busy area. And what the future is going to bring, I don't know, but they're certainly talking about all kinds of green, energy out there, and putting up wind farms is one thing, but they're also talking about generating power from tides, and using the tides, which are very strong in the Golden Gate, to power turbines that can generate electricity. It's a great idea, but when you think about giant whirling sharp blades, and you've got porpoises and dolphins and whales right in the same area, that also causes us a lot of concern. So we'll see how that develops in the future, but there's a lot to be concerned about, but there's a lot we can do about it too. And so the last thing I want to mention is that you can participate and help our research by just sharing your sightings. If you see some interesting cetacean sightings, whale sightings, you can go to marinemammalcenter.org. That's our website. And there's a report an animal form at the top. And there's one specifically for whales and dolphins. And just let us know. It just goes to our team. that information, and we can respond to you. You can ask questions of us too if you want, through that mechanism. And with that, I'll stop sharing so that we can maybe have some questions and answers. What do you say, Sarah?
Fantastic, Bill. That was just epically exciting and new stuff and stuff I've never seen before. Those photos were jaw-dropping. The gray whales with
Yeah, I never thought I'd see gray whales lunging out of the water after fish, but it happened.
It happened. Wow. And your shot of the humpback with the fish and the gull, that was exceptional. Your photos are beautiful.
Well, that's good. That's good. I mean, one of the things we have to think about too is, are these weird behaviors like humpbacks going after, I'm sorry, gray whales going after fish? Is that something we should be concerned about? And in a way, it is, because there are probably some of these whales either weren't getting enough food or decided not to make the big migration to Alaska, so they've got to find alternate forms of food. It shows that they're flexible and that they're resourceful. And that's how come gray whales have lasted for the last 100,000 years, where there's been glacial advances and retreats. They've seen climate change like more than we've seen, I'll tell you that. And they've survived all that time. But things are accelerating now. And so eating fish may be one of those signs that, whoop, they've got to figure out a different way to make a living.
Wow. I think we were photobombed. We had one of our early, not an ROV, but a drop cam. And we were photobombed by a gray whale that was absolutely scooping up a big patch of krill right there near one of our last rocks.
And that's great.
I'm really curious because there was quite a few years here up in Mendocino, McCarricker, all along here, and the Mercers saw it too, where there were gray whales pretty much all summer moving from point to point in Mendocino in great numbers. And then like this year, not so much. And last year, not so much. But the prior 3 or 4 years, they were everywhere. And now this summer, we've had just an explosion of humpback. So it's just so fascinating to see how dynamic they are and how, and just getting people tuned in and noticing what's going on out there is great and inspirational. So
well, I agree, Sarah. And the thing to remember is that if you've been looking at these animals for as long as I have, you've got a different baseline, meaning for many, many years, you couldn't see them. I mean, humpbacks coming up near, no, you wouldn't even see that for decades. And that was, hunting, whaling was the root cause of that. But still, what we're living in a time where you can see lots of species, you can see a lot from shore, more than you ever could. So we're lucky in that sense that we get to see this happening in front of our eyes, but it also brings some responsibility with it.
Sure. Wonderful. Let me see if I can get to some of these chats. People are saying things. Let's see. Incredible photos, great presentation. Thank you so much. Fabulous amount of information and fabulous images. Are the Pacific Coast feeding group whales any different genetically from the Alaskan population? Good question.
That's a super good question to ask. Are the Pacific Coast feeders genetically different? So we've just literally a week ago, we're talking to Oregon State researchers about that exact question. And the answer seems to be they're not really genetically different, okay? But they're maybe culturally different, okay? So when you have kind of, intelligent animals, you've got some large brains, and you've got long-lived animals that teach their young, you can start having different cultures. That is, how do they make a living differently? And so while they may not be genetically different, that's probably because when they go to Baja, they're mixing with all the other 14 thousands of other whales down there, and so they're not becoming genetically distinct, but they come back every year. They have what's called site fidelity. They're faithful to their feeding areas. They come back and they've learned how to navigate in there. Now, but the other thing that the Oregon State folks have found is that they're slightly smaller than the Alaskan whales, that they just don't seem to grow quite as big. Now, that could be because they're not quite getting enough food, but it could also mean that it's the small maneuverable whales that can handle the rocky coast in Oregon and Washington and Vancouver to get the kind of food they're getting, instead of just going out into the big flat meadows, underwater meadows in Alaska, and feeding on the bottom. So their different lifestyle has meant they have become a little different, but it's just not really at the root DNA level.
Have you noticed any time of day, a preference for any of those cetacean species feeding or otherwise passing through the strait? Yeah, is there any time that's better or not?
So, like I said earlier, the best time, the time that I go onto the Golden Gate Bridge to look is high tide. So just, it changes every day. So you've got to check your tide chart and go out. And I go out about an hour before and I stay an hour after. So go out for a couple of hours. And so that's best for like the small cetaceans, like the harbor porpoises. The humpback whales also tend to be closer to shore and in the bay at high tide. They sort of ride the tide in and ride the tides out. And they don't have to. They can obviously swim against it, but they tend to go with the tide. So high tide is, again, better for humpback whales. And gray whales are very hit and miss. We just don't really have a pattern for when they're feeding. But those two are the ones that we see feeding humpbacks and harbor porpoises at high tide.
Nice. I can't wait to go and walk across the bridge at high tide. Could you comment on the capability or compatibility of the gray whale and humpbacks non-competing?
That's a good question too. So one of the things we looked at in Pacifica, where you had a half a dozen gray whales every day feeding in this area, humpbacks started coming in too. And they mostly stayed apart. Sometimes they got within 10 feet of each other, but the humpbacks are a lot bigger. And I think the gray whales tended to sort of move off a little bit when the humpbacks were right there. So the humpbacks probably can outcompete the gray whales in deeper water, but the gray whales were in super shallow water where the humpbacks weren't going to go. So they sort of figured out some little separate areas in Pacifica and were able to, sort of be together. But remember, that was only for like 3 weeks. And then the anchovies moved out or were depleted. And that was it. The gray whales didn't stay around to keep feeding on the bottom or doing anything else. So that was our sort of one time where we really got to see some humpbacks and gray whales near each other.
Right. I have earlier this year, and now I'm forgetting what month it was, but some of the last grays were moving north. And I was like, oh my gosh, there's some humpbacks coming south. And it looked like they were on a collision course right off the Mendocino headlands. Someone is saying, Vivian, you said you were here for 5 weeks camping out in August and September and saw lots of spouts. And that's what we've been seeing basically all summer. Lots of spouts, like literally, pretty much any point of land that you look out within about a mile ashore. There are humpbacks everywhere out here. On the pelagic trips, we're seeing them. I don't know how many we saw, 20, 30 whales on our last pelagic trip. So, and they really have been consistently here. So I would guess that they were humpbacks, unless of course you saw a really tall spout. And then I'm going to say it was a fin whale or a blue whale, which happens frequently up here as well. Not as frequently as the humpbacks. But, I grew up here. I'm celebrating my 50 years of living on the coast. And these last few years have been more whaley than I can ever remember.
Yeah. I mean, part of that is due to the fact that we've had an extreme amount of anchovies along our coast. And I've spoken to the NOAA fisheries biologists recently about that. And they said that the numbers for anchovies are really off the charts. So along our coast, particularly, say, Monterey Bay to San Francisco, they've had this either sardines can be big years like they were in the 40s and 50s. But then in cooler water times, you get anchovies coming up. And yet we've had some heat waves. So why that should be bad for anchovies, but they're saying they've just never seen such densities of anchovies over the last, say, 5 years. So, and it's still continuing.
Right. Maybe concentrated around little bits of upwelling, or
well, it has to do with, yeah, the productivity of the water and the upwelling. And I mean, you know, a lot of the United States suffered under tremendous heat, but we didn't.
Right.
So that's from the winds coming across, and that wind is what's moving the water surface and creates the upwelling that creates the productivity with sunlight and the plant plankton. And so here it is. We are really recipients, of the whales are the recipients, literally, of the bounty of our local ocean.
Great way to escape doom and gloom. If you look at the summer we just had, and the fall that we're having. Let's see, I want to make sure to get to everybody here. Really interesting talk. Has there been communication with Alaska Department of Fish and Game about the poor feeding quality, perhaps overfishing? Have there been changes in fish management in Alaska that you know of?
So the gray whales that we're talking about that go to Alaska don't feed on fish. So fish really isn't the problem. It's really these invertebrates, these worms and little crustaceans that live in the mud, actually live down in the substrate. There's a paper that's just about to come out. It's been accepted in Science. And the title of it is Gray Whales in the Boom Bust Cycle. And what they're saying is that gray whales have experienced this in the past, where they have sort of overrun whatever nature provides in the Arctic for their food. Now, the difference, of course, is that this time there seems to be human-caused climate change that's affecting the ice cover. And when ice goes away, you'd think, oh, perfect for gray whales because they have more habitat they could expand in. The problem is that winds race across this water, stirs up the water, and that affects what's growing underneath in the bottom muck. There may be less light coming in because the water is more turbid. It's a very complex system that definitely don't have down 100%. These are the best theories they have, but that paper will explain in the best I've ever seen of sort of that, yeah, climate change is affecting these guys, and we may see more or worse of these boom bust cycles for gray whales in the future. So it's not really a fish issue, it's like a different one.
And Sherry was wondering if there was any, Sherry's one of our photographers who's out there.
Yes, I know.
Listeners, and she was just wondering if there was any update on the body condition of the Pacific Coast feeding group grays, like a body score maybe more recently.
So the paper, the paper that came out that we talked to Lee Torres about this is by Bierlich. You can look it up, Bierlich, recently, last year. And so they go through that, but I can send it to you too, Shari, after the presentation.
Great. Let's
title of it.
Well, it's I have to look it up. Let me look it up for you, and I'll tell you.
What's the journal?
Got it here in my let's see. It is called yeah, here it is. It's from this year. It's very recent. So it's by a woman named Bierlich, Bierlich. It's called Downsized. Gray whales using an alternative foraging ground have smaller morphology. And that's what I mentioned about their smaller size, but they also go into their body condition too. So
how's the population of fish and krill doing in San Francisco Bay? I mean,
so krill, there is no krill in San Francisco Bay to speak of, not the kind of blooming midwater krill that you see the whales feeding offshore. So that's an offshore phenomenon that's just not in the bay. But the fish are doing fantastic. I mean, we've had just amazing years with huge amounts of anchovies going back several years. And I think the whales finally sort of discovered it or followed it in and then realized, oh my gosh, there's a whole nother feeding ground here. And so they've been back every year since 2016.
I love that. That's great. Lots of questions about where on the bridge to look at, and north and south and different things. But let me just, I have a Morning had your hand raised. Did you have a question? Go ahead and unmute. You need to unmute yourself. There you
Usually just the I was in Pacifica and saw that frenzy. And what was really interesting to me was the actually the pelicans were all involved in it too. I mean, it was like pelicans and whales and every kind of fish and whatnot. And I have never seen such a thing. And I just wondered, I mean, is there any particular reason why all the krill was coming like that in that fashion?
So those were all anchovy. Okay, it's all fish, and they're stacking up. They were stacking up near shore, and which they do from time to time, and that could have some of the root causes of that could be warming water and stuff. They tend to compress near shore when they're trying to avoid certain kinds of water. And so they were really close to shore, which made it easier for the gray whales to sort of attack them there in their dense shoals versus humpback whales. But in our paper that we're just about to submit on this, where you can read more about the details of this, we had many species of seabird, were there. Thousands and thousands of seabirds were there, and bottlenose dolphins, harbor porpoises, California sea lions. I mean, they were all there getting these anchovies. And so one of the things that's been suspected too is that the bird activity can actually help the whales because they're pounding on the anchovies and concentrating and forcing the anchovies together, and that's better and more efficient feeding for whales.
Wow. Very cool.
Fascinating. Thank you again.
Yeah, Vivian says, fabulous information. Thank you. We're going to support the Noyo Center and the Marine Mammal Center. Please continue these talks. That's such great feedback. We really, it warms our hearts, and it's great to show love for the scientists who are out there working and dedicating their lives to sharing this information with us. When we can come to a talk and ask a question that's been bugging us for years, and there's like an answer and some scientific information that maybe we wouldn't get. So I'm loving these talks online just for that reason, that we can all get together. Yeah, we're not getting together in person, but maybe we have a more dynamic group and we didn't have to drive a bunch of miles and cram into a building. So we love this. Support your scientists, support your nonprofits. And gosh, Bill, thank you so much. And if I missed anybody's questions, forgive me. One last thing, I'm just going to be mean because I've got the microphone, but I had with the gray whale feeding between Mendocino Point, they were swimming between little remnant kelp forest to remnant kelp forest. And I wondered, without the big kelp forest, if there was a concentration of the krill right around the remnant kelp forests that were literally, 50 yards or so.
It could be. So there's a kind of shrimp they call mysid shrimp that hang out near the kelp forest. So yeah, the change in kelp forests could have an effect on that. I know that certainly in Washington and Vancouver, they will target those mysid shrimp in the kelp areas, in the rocky reef areas.
Yeah, it was the mysids. Exactly. Thanks for that. Great. All right. Well, thank you, everyone. Thank you, Bill. We'll hope to see you soon. Get in touch with us at the Noyo Center if you want to come visit us, and keep whale watching and happy whale, report what you're seeing and all of that. And have a lovely evening. Thank you.
Thanks for having me, Sarah.
It was really a pleasure to have you.
All right.
Night.
Thank you.